Hello there and welcome to Help Grow Academy. In today's class, we'll be solving over 10 most repeated post-UTME questions on physics. The first question we have says, which of the following quantities is a vector? Which of the following quantities is a vector? Option A, we have mass, B, we have speed, C, we have work, and D, acceleration. The first thing here is to know the meaning of the word vector. What does vector mean? A vector quantity is a quantity that has both magnitude and direction. Vector quantities has both magnitude and direction. If a quantity is not a vector quantity, it is a scalar quantity. If a quantity is not a vector quantity, it therefore means that quantity is a scalar quantity. From the option here, we have mass, speed, and work. These quantities are scalar quantities because they have what? Magnitude but no direction. Mass here has magnitude but it doesn't have direction. So therefore, it is wrong. It is not a vector quantity, it is a scalar quantity. Speed here has magnitude but it doesn't have direction. So it's also wrong. It is a scalar quantity. Work, we know work to be what? The force times distance. It has magnitude but it doesn't have direction. So it's wrong. The correct answer here is option D, acceleration. Acceleration is a vector quantity because it has both magnitude and direction. So this is our correct answer. Acceleration has both magnitude and direction. Question 2 says, a boy moves with a uniform acceleration from rest and attains a velocity of 20 meters per second in 5 seconds. What is the acceleration? A boy moves with a uniform acceleration from rest and attains a velocity of 20 meters per second in 5 seconds. What is the acceleration? Option A, we have 2 meters per second squared. Option B, we have 4 meters per second squared. Option C, we have 5 meters per second squared. And option D, we have 10 meters per second squared. Solution. The first step is to recall the formula for acceleration. They said, what is the acceleration? So recall the formula for acceleration. What is acceleration? Acceleration is the change of velocity. The rate of change of velocity. That is what acceleration is all about. The rate of change of velocity. When you hear the word rate, what should come to your mind is time. So, mathematically, acceleration is expressed as A is equal to change in velocity all over t, where A here is equal to the acceleration V is equal to the final velocity U here is the initial velocity and T is the time. So from the question, it says a body moves with a uniform acceleration from rest and attains a velocity of 20 meters per second. It moves with a uniform acceleration from rest. This body is moving from rest. Therefore, the initial velocity u here is equal to 0 meters per second. Reason being that it's moving from rest. We have gotten u, the initial velocity, to be 0. It attains a velocity of 20 meters per second in 5 seconds. So the final velocity v is 20 meters per second. It gave us time to be 5 seconds. So we have time here is equal to 5 seconds. Now we have this. Let's impute these values into this formula. We have A is equal to, V is 20 meters per second. So we have 20 minus U is 0. The initial velocity is 0 divided by time t. T is 5 seconds. So we have 5. A is equal to 20 minus 0 is 20 divided by 5. 20 divided by 5 gives us 4. Don't forget the unit for acceleration is meters per second squared. So we have meters per second squared. That is the unit for what? Velocity. So the correct option here is option B, 4 meters per second squared. Okay, question 3. The slope of a velocity time graph represents A, distance, B, acceleration, C, displacement, and D, speed. The question says the slope of a velocity time graph represents A, distance, B, acceleration, C, displacement, and D, speed. The velocity time graph is a graph of velocity against time. Is a graph of velocity against time. To get the slope which is also the velocity gradient, S is equal to the change of velocity, change in velocity all over time. To get the slope of a velocity time graph, this is the formula we use. Slope is equal to change in velocity all over time. And mathematically, we know that change in velocity represents acceleration, because acceleration here is change in velocity all over time, which is, from the previous question we solved, we have that acceleration is equal to V minus U all over t, where V is the final velocity minus the initial velocity over time. So the correct option here is option B, acceleration. The slope of the velocity time graph represents acceleration because it talks about change in velocity over time. Question 4 says, a mass of 2 kg is acted upon by a force of 10 newtons. What is the acceleration? A mass of 2 kg is acted upon by a force of 10 newtons. What is the acceleration? Option A, 0.2 meters per second squared. Option B, 5 meters per second squared. Option C, 10 meters per second squared. And option D, 20 meters per second squared. Now, in this question, let's write out the given parameters. It says a mass of 2 kg. So you are given mass to be 2 kg. It says acted upon by a force of 10 newton. You are given force to be 10 newtons. They say what is the acceleration? Acceleration is unknown. Now, some persons, when they see this question, they will rush and recall the formula for acceleration, that acceleration is equal to change in velocity over time. If you use this formula, you're wrong. You won't get the answer correct. You work with what you have in the given parameters. Recall Newton's second law of motion that says F is equal to ma. This is from Newton's second law of motion. That the force is equal to the mass times acceleration. From the question, we have mass we have force, but we don't have acceleration. So what do we do here? In this case, we make acceleration the subject of formula. If we make acceleration the subject of formula, we have that A is equal to F over M. Now we have made acceleration the subject of formula. Let's substitute these values into this equation. We have that A, acceleration, is equal to F over M. Our F here is 10 newtons, divided by our M. Our M is 2 kg. So A is equal to 10 divided by 2 gives us what? 5. Don't forget, the units for acceleration is meters per second squared. So the correct option here is option B, 5 meters per second squared. Question 5. Question 5 for today says, if a material returns to its original length after being stretched, it is said to be A, ductile, B, plastic, C, elastic, and D, brittle. If a material returns to its original length after being stretched, it is said to be dash. If you have been part of this class for a very long time, you notice that this is a bonus question. If you have been part of these tutorials, you notice that this is a bonus question. Now it says, if a material returns to its original length after being distorted, it is called an elastic material. An example is your spring. An example is your spring. Now let's know the meaning of all these other words. Ductile here simply means the ability of a material to be drawn into wire. It simply means ductile simply means ability of a material to be drawn into wire. Plastic here, plastic refers to materials that cannot return to their original shape or size after being distorted. Materials that do not return to their original shape after being distorted. That's what plastic materials are. The next we have here is elastic material, which we have explained. The elastic materials we have explained it. We said they are materials that return to their original shape and size after being stretched, after being distorted. Brittle here, brittle. This refers to materials that, when deformed or when distorted, they break. The ability of a material to break. The ability of a material to break when distorted without any significant deformation. So that's what brittle materials are. So the correct option here is option C, elastic materials.